Hello friends, after learning derivatives using first principle and composite function, this is right time for us to learn derivatives of inverse trigonometric function. In short, what do you mean by inverse trigonometry? I'll give you a simple example to understand. If y is a function of x, then x is f inverse y, is inverse function. But as far as inverse trigonometric function concerned, what you are watching on the board at the moment are these 6 functions called inverse trigonometric functions. That is sin inverse x, cos inverse x, tan inverse x, cot inverse, sec inverse and cosec inverse. The basic formula what we use is dy by dx, that is y when differentiated with respect to x is equal to 1 upon when x differentiated with respect to y. It simply means that when you differentiate y with respect to x multiplied by x with respect to y, you ought to get answer 1. So they are reciprocals of each other. But that is the theoretical part. What exactly we need is the list of these formulae. For your convenience, I have already written on the board. Just have a look. Simple formulae to understand. Here we are not covering the derivations of this part, nor we are at the moment writing what the domain and range for this x. It is presumed that this x falls in the said category. We are directly writing formulae for inverse trigonometry derivative, not going into much detail of what x belongs to, because that's altogether different part which will be covered under the topic called inverse trigonometric function. Alright, have a look. Derivative of sin inverse x is 1 upon root of 1 minus x square. Now, when it comes to cos inverse, it is just the change in sign. It is minus 1 upon root of 1 minus x square. So, you have to remember only one expression. There is plus sign for sin inverse, there is minus sign for cos inverse. Next comes is the tan inverse and cot inverse. See the similarity between formulae. It is 1 upon 1 plus x square, and for cot inverse again minus 1 plus x square. Have a look. For sec inverse x as well as cosec inverse x, you got similar formula. For sec inverse it is plus 1 upon x root x square minus 1, and for cosec inverse x it is minus 1 upon x root x square minus 1. See, you should observe for cos inverse, for cot inverse and for cosec inverse there comes a minus sign. Okay. So students, we will elaborate our idea of differentiating inverse trigonometric function by considering few examples. Look at the first example. Y equal to sine inverse of x square minus 5. Now you have studied the formula for sine inverse x. It is 1 upon root of 1 minus x square. But this is not x now. So this belongs to not only inverse trigonometry but also to composite function part. Have a look. So in that case, what do we do? So we differentiate sine inverse as its original formula 1 upon root of 1 minus whatever present here, its square. 1 upon root of 1 minus x square. So x was here, so its square. But this was not x, it was x square minus 5. And therefore, derivative of x square minus 5 has to be written to multiply this. That's what it was taught in the previous topic called composite function. So 1 minus, just expand this using regular formula, and derivative of x square is 2x, derivative of 5 is 0. And then simplify, this 2x comes here, and then 1 minus 25 is minus 24. Minus of x raised to 4, minus minus plus 10 x square is the final answer. Okay, students, hopefully you have understood. So this was the problem which belonged to inverse trigonometry as well as composite function. We go to the next problem. Have a look. Y equal to cot inverse of 1 upon root x. Now you might feel there was a cot inverse expression and suddenly it got tan inverse. So that comes from inverse trigonometry formulae. Cot inverse of 1 upon x is tan inverse of x. It's the reciprocal part. You can go through inverse trigonometric function list of formula, you will realize that this is a true formula. Now derivative of tan inverse. In the list of formulae, we have written tan inverse x derivative 1 upon 1 plus x square. So it is 1 upon 1 plus whatever you write, its square. And then because it was not x, you got to multiply by derivative of root x, which you know it is 2 root x. Square of root x is x. So final answer is 1 upon 1 plus x into 1 upon 2 root x. Yes, students, now we have a very important problem on the board. Y equal to tan inverse cos x upon 1 plus sin x. You see, tan inverse of x has a formula, but this one something awkward has come. But you should rightly remember formula for trigonometry for cos x 1 plus sin x in terms of half angle formula. However, what we should do is replace cos x by its half angle formula, cos square x by 2 minus sin square x by 2 is the formula for cos x. And what about 1 plus sin x? You see, it is cos x by 2 plus sin x by 2 the whole square. So this one is a formula for 1 plus sin x and this one for cos x. Now look at the numerator, a square minus b square. There is a formula, a plus b, a minus b. So what can we write? Cos of x by 2 plus sin of x by 2 into cos of x by 2 minus sin of x by 2. Have a look. Now this remains as it is, cos x by 2 plus sin x by 2 the whole square. The moment you write this, you know there is a common factor from numerator and denominator which you can cut. What remains is this expression. Always remember, in problems such as tan inverse, you should try to get 1 at this place. How to get 1? Dividing numerator and denominator by cos x by 2. When you do that, what you get is y equal to tan inverse of, you see, cos x by 2 upon cos x by 2 it is 1, sin x by 2 upon cos x by 2 it is tan x by 2, divide by cos x by 2 upon cos x by 2 1 plus sin upon cos it is tan of x by 2. This is your expression. There are trigonometric inverse formulae from which we can write y equal to tan inverse of 1 minus tan inverse of tan of x by 2. Have a look. Is it not? Now this is converted to this using trigonometric inverse formula for tan inverse. Now what is tan inverse 1? It is pi by 4. Everybody knows that. Minus, what is tan inverse of tan? It gets cut. What remains is such a simple expression where you can differentiate y with respect to x as 0 for pi by 4 and half into, what's the derivative of x? 1. So it is the final answer. Students, now we will see one example which is based on method of substitution. Have a look at the sum. Y equal to tan inverse of 3x minus x cube upon 1 minus 3x square. Now this expression is too big. You can solve it using method of composite function taught couple of minutes back, but the better way is to substitute something. What to substitute? We will try to substitute something which will simplify this expression. Look at the expression. If you put x equal to tan theta, obviously theta becomes tan inverse of x. X is tan theta, theta is tan inverse x. What does this become? Tan inverse of 3 tan theta minus tan cube theta 1 minus 3 tan square theta. I know that this is a known expression and this is the formula for tan of 3 theta. So y becomes tan inverse of tan theta, which can very well cut this. What remains is only 3 times theta. 3 remains as it is. Theta can be replaced by tan inverse of x and hence its derivative is 3 into derivative of tan inverse x, which is 1 upon 1 plus x square. So I request students to go through the entire content again and again. Please refer to your friends, and if you like it, please press the bell icon, subscribe my channel, and if you have any query, please feel free to contact the number given below. Thank you.